Now, in this part, I would like to show you the power of knowing the S parameters for a network if the conditions do change. As you may remember from the previous video, the main idea here is that in order for me to calculate the S parameters, I must terminate the network to its own characteristic impedance for each port. For example, when I did the calculation for S21, I had to make sure that A2 and A3 are equal to 0, which means that each of the ports 2 and 3 have to be terminated by their own characteristic impedances. That is necessary to calculate the S parameters. But once the S parameters are known, I can actually use them to find out what happens to my network if conditions do change. So I want to show you an example here of doing exactly that by utilizing the S parameters of the electrically small three-way splitter and show you what would have happened if one of the ports now is terminated at a different impedance. For example, I'm going to assume that for some reason, intentional or accidental, the port 2 impedance has been changed to a short. So I'm going to assume that port 2 is essentially shorted out. And now the question is, tell me what, for example, will be the reflection coefficient in port number 1. So I want to find out, let's say, gamma in, the reflection coefficient into port number 1, given that my port 2 is shorted. The impedance in port 3 will be assumed unchanged from the S parameter calculation. That means the impedance in port 3 will be assumed to be equal to Z0. Now, this is a very simple network, and you can very quickly find out what the answer is. Clearly, I have a short in port 2. Clearly, this electrical length is practically 0, so that means it is essentially as having shorted port 1. So the reflection coefficient from port 1, gamma in, must be equal to -1. It really doesn't take much calculation to get this thing done in this particular case, but if you had an actual more complex network, knowing the S parameters would allow you to avoid the calculation which I just did here, which in that case it would have been a lot more complicated. So let me show you how you could have done this calculation very formally, and hopefully if we do things correctly, we'll find out that gamma in is going to be equal to -1. It's essentially, in terms of our power waves, it will mean that if this is A1 and this is B1, hopefully we'll find out that B1 is equal to -A1. All right, so what we do is we start with our S matrix, and this is the S matrix that we have calculated for our device. And this S matrix is going to be equal to our port 2. This S matrix is going to be useful for us to calculate the result when port 2 is actually shorted. Now, since my port 2 is being shorted here, that means that if I have the A2 here and the B2 here, oops, I actually am putting them the wrong way. So let me redraw that. So this will be my A2, this will be my B2. So if I have that, because I have a short into port number 2, that means that A2 will be equal to -B2. That's the definition of having a short into port number 2. Now, if I look into port number 3, nothing changed from what I had before. That basically means that A3 is equal to 0 because that port is terminated to its own characteristic impedance. So I can go ahead now and write my S matrix equation in its full glory, which you will see here. So for example, I wrote down that B1 is equal to S11A1 plus S12A2 plus S13A3, and use the knowledge I have for the terminations, the new terminations, to essentially simplify the expressions. For example, my A2 is equal to -B2, and you can see that replacement has happened for all of these cases. And my A3 has also been made equal to 0, and so those terms have disappeared. So now I wrote the expressions for B1, B2, and B3 as a function of A1, A2, and A3, and I utilize what I do know for some of these waves. A2 -B2 and A3 is equal to 0. From now on, it's really just a matter of algebra to find out B1, B2, and B3. For example, if I take the second equation and I utilize the fact that S22 is -1/3 and S21 is 2/3, then I can basically find out that B2 is equal to A1. Then if I use this result, I'll find out that B1 is negative A1, as I should have, and then B3 is equal to 0.